Hey guys, and welcome back to the final part. So in this video we're going to go through literally the remainder of the questions. So at the moment we're on question 19, and altogether we're going to go all the way up to question 24. But anyway guys, without further ado, let's just jump straight in. So number 19. So it says that the table gives information about the heights of some trees. Okay, so you got heights and frequency, and it looks like we got about 15 trees with a height between 0 to 20, 48 between 20 to 35, and so on. Now on the grid below, they want us to draw a histogram for this information. Okay, cool. So guys, every time we're going to use a histogram, we always need to firstly understand what is the frequency density and what is the class width. Okay, so these are your two components you need. And I always like to draw like this. I always visualize some sort of x and y axes. I always draw a bar, because that's what histograms are. They're just nice bars. I always label the inside of it the frequency, so that's kind of like your area. And the width, I call it the class width. And the height, I call it the frequency density. Okay, now looking at this data, we only have the frequency, but we also got the class width. So if we add like another column here, call it CW for class width, we can see that the class width for the first group is between 0 and 20. So 20 take away 0 is 20, 35 take away 20 is 15, and so on. Next one is 5, and the last set is 10. Now I also like to include a frequency density, because this is going to be your y-axis, yeah? So that's what we need. We basically need the height of the graph. Now to calculate frequency density, from this formula, you can see that the frequency equals the class width times the frequency density. It's like base times height. This means that the frequency density itself is always equal to the frequency divided by the class width. Okay, so let's have a look. For the first one, we got 15 over 20, which is 0.75, 48 over 15, so just put that in the calculator, and you should get 3.2. Next one, 21 divided by 5 is 4.2, and the last one, guys, 16 over 10 is 1.6. Okay, and that's it. Now all you want to do is literally plot this on a graph. So conveniently, guys, they kind of did it for us. They put 0 to 5 for the frequency density, so our numbers look like they'll fit. And for the x-axis, they got, well, they call it a height, but this is pretty much our class width. It's these values here. So let's do it. So we can say from 0 to 20, there's area of 15, so up to 20. We know that the height goes up to 0.75. So let's draw it. So we know that this is going to be 0.5, so 0.75 should be all the way here. So just draw a straight line hitting 20. And that's really it. And you're just going to repeat this every single time. So for the next bar, we're going from 0 to 20 to 35. The height is 3.2. So for between 20 and 35, that's what it was, right? 35. We're going to go all the way up to 3.2. So 3.2 is basically here. Yeah, and that's it, guys. You literally just have to rinse and repeat this. And that's it. And you're pretty much done. Yeah, so let's move on. Now, number 20. Okay, we've got A, B, C, and D are points on a circle. Okay, so before we even look at the shape, let's try and identify what it is. First things first, when we look inside the circle, we have a four-sided shape. So when you've got a four-sided shape where each point touches the circle, this is actually known as a cyclic quadrilateral, yeah? Now, one property of the cyclic quadrilateral, guys, is that the corners, the angles on each corner, sum up to 180. So for example, we can call this angle here A, and at point C we can call it C. This tells us that A and C must sum up to 180, or B and D also sums up to 180. Okay, another thing we can notice is that these two lengths appear to be the same lengths, yeah? So we'll come to that in a second. Now according to the info, it says A, B, C, and D are points in a circle. TDV is a tangent to the circle. So tangent means it touches at one point. So we can see that this is angled at 71. Okay. The length of AB equals AD, so we saw that earlier. Work out the size of angle BCD and then give a reason for each stage of your working out. So guys, the only way to work out this angle BCD, so we're talking about angle C, is to somehow begin and relate angle 71 with the tangent and this random chord, yeah? And the only one I can think of right now is something known as the alternate segment theorem. And it looks a bit like this, the formula. The alternate segment theorem tells us that if you've got some angle B here, then and a tangent and some sort of chord, then wherever this angle is, it's going to be equal to the other side of it. But the shape has to be a triangle first. So let's just do it right now, guys, yeah? At the moment, we got quadrilateral. So let's try and rewrite this as a triangle. So you got your chord, you got your tangent. I'm going to draw a straight line from B connecting to D, yeah? Now this tells us that if you got 71 here, then on the other side of the chord, so we're talking about the other side, so over here, this angle here, just the first bit of it, let's call it X, equals 71. So not the whole B, but just this part. Now another useful property, guys, yeah, is that because you got some sort of like equal lengths here, we actually got an isosceles triangle secretly here. So this means that this part here is also 71 degrees. Okay. And because you got that information, you can now work out what A is. And we know that all angles in a triangle always adds up to 180. So we basically have A plus 71 plus 71 gives us 142, and it's supposed to equal 180. This means if you minus 142 across, this angle A is now going to equal 38 degrees. And that's it, guys. Now finally, like if we go back to the cyclic quadrilateral rule, we said earlier that angle A and C sum up to make 180 as well. Now because we know that A here is 38, we can easily work out C. Well, if you subtract 38 to this one, you're going to go back to a C value of 142 degrees. And that's the answer, guys. The angle BCD is 142 degrees. And yeah, that's it. Alright, number 21. So a solid is made from a hemisphere and a cylinder. Okay? So the plane face of a hemisphere coincides with the upper plane face of the cylinder. Okay, so just to label this carefully, this bottom deck is actually the cylinder, and the top half is half of a sphere, so it's also known as a hemisphere. Okay, so we're going to see what formulas we need before we actually answer this. Now, on the next part, it says that the hemisphere and the cylinder have the same radius. Now, this is because they're both like decked up in the same way. So you can imagine there's a radius here, and the bottom half also has a radius like that, yeah? The ratio of the radius of the cylinder to the height of the cylinder is 1 to 3. Okay, cool. So if we just imagine we've got some vertical height like that, yeah? Let's call it h. What he's trying to say here is that the radius of this shape, if you imagine as one part, must be equivalent to this side as if it was 3 parts. So this is basically 3 times the radius. So let's just call the radius x for a second, yeah? Let's let r equal x. That means the height must be 3 times x, okay? Given that the solid has a volume of 792 pi centimeter cubed, work out the height of the solid. Alright, cool. Let's have a go. So to work this out, guys, we just need to work out the volume of the hemisphere and the volume of the cylinder. Well, thankfully, we know both the formulas. We can say that the volume of the cylinder is just pi r squared height, h, and the volume of the hemisphere is actually half of a sphere. So if we know a sphere is just 4/3 pi r cubed, that means half of this would just be half of 4/3, which is 2/3. So if I just delete this one and just write 2/3, so just 2/3 of that shape. Yeah, and it's telling us that the combined total equals 792 pi. So let's write down here, yeah? We can say that the total volume V equals the cylinder, so pi r squared h. So instead of r and h, I'm going to replace r with x and h with 3x. So it can be pi x squared and then 3x plus the other shape, the hemisphere. So 2/3 pi x cubed. And all of that's supposed to equal 792 pi. But we'll get to that in a second, yeah? Now, if we go ahead and multiply this term out here and just replace the volume with 792 pi, we now got 792 pi equals pi times x squared times 3x. That's just going to give us 3x cubed pi, okay, plus 2/3 pi x cubed. Okay, so when you look at all of these terms here, they each have a pi, so that means we could just cancel them out. So let's just delete the pi across. So these all cancel out, and then if we just tie this up now, we now got 792 equals, well, we're just left with 3x cubed plus 2/3 x cubed. Well, 3 plus 2/3 is actually 11/3 and then x cubed. And now we just rearrange to make x a subject. So in your calculator, guys, and we can do this all in one go, we can do 792 divided by that fraction, 11/3, and that equals x cubed. And then in your calculator, if you do that, you should get 216. Okay, so 792 over that is 216. And now, conveniently, if we cube root this, we're going to get a perfect answer of 6. And that's it, guys. We got x result 6. And remember, x here represents the radius, right? So to get the height, it's going to be 3 times x. So 3 times 16 means the height is going to be 18. So it's 18 centimeters. And that's it, guys. Sorry, guys. They want the height of the solid, not the height of the graph. So actually, the height of the solid is the whole thing up. So one more thing. So we know that this is the height. That means the radius, because we're dealing with sphere, if this is the radius, then this is also the radius. Because remember, it's the same all the way around. So actually, this length was 3x. Our height was x. So actually, we're trying to work out 3x plus x. So we want 4x. We want the total height, yeah? That means the final result, which is going to be 4x, is going to be 18 plus 6, or 6 times 4, by the way, which is 24 centimeters. And that's a real height, guys. The result here should be 24. Okay, let's go down. So the graph of y equals sine x for x between 0 and 360 is drawn on the grid. Okay, so here's our natural sine wave graph, where our peak is always at 1 and the other peak is at -1. And this is just one complete loop from 0 degrees all the way to 360. Okay. Now on the grid, we need to draw the graph of y equals 2 sine x plus 30 for x between 0 to 360. Okay. So how to convert a sine x regular sine to 2 times sine and x plus 30? Well, let's look at the first digit, the 2, yeah? What this tells us that the graph now is being doubled, okay? So to double this kind of graph, it just means that if the height was 1, we now double 1 to 2. So this means that the peak of this shoots up to here. And likewise, if the peak at the bottom was -1, then this now shoots to -2. Okay, so now we know how high it shoots. What about x plus 30? Well, this just tells you where the coordinates on the x-axis will shift. So this means that they all shift 30 degrees. Now be careful, guys. It says x plus 30. This doesn't mean you shifted to the right by 30 degrees. In fact, you shifted to the left by 30 because it's always inverted inside the bracket. So what I'm trying to say is that we're going to now move everything this way by 30 degrees. Okay? So if you think about, if we drew the original graph for a second here, so let's use a dotted line. This means that this point here would have been over here. This point here would have been over here. So it would have been something like this, 30 degrees to the left. And then likewise, this would have been here, this would have been here, and so on. So let's just see how it looks like. So this is going to be our peak. It shoots like that, hits at this point, 30 here, 30 to the left here, 30 left here, and 30 left there. So it looks a bit like that, guys. So here's our new peak up here, and you just follow along until it hits here. Perfect. So that's exactly where it should be. Now this was the 30 degrees to the left bit. So if we're going to shoot this upwards, this means that the new peak would be here, and the new bottom peak would be here. Okay, and the new 180 is going to be this over here. And likewise, the new 360 is here, and this peak shoots up. Well, double this peak will go up to here. So let's try and plot this, yeah. And oh yeah, last one. This peak over here shoots up to here. So yeah, let's just have a go. So if I'm going to do this right now, I'm going to connect all the purple dots. So it's going to look like this. And then this one's going to shoot all the way down to here. And now we need to get to this point here. So it's going to curve down here, curve back up, and then lastly end at this point here. Okay, so almost smooth. But yeah, that's basically the main idea. Just smooth it up. Now for part B, which is completely unrelated, guys. Write x squared minus 6x plus 10 in the completed square form, by the way. So this is always completed square, where a and b are integers. Okay, so simply to complete the square, all I do, guys, is I always underline the first two terms, yeah? And now all you gotta do is also wrap this up in some sort of square format. The trick is to firstly open the bracket, copy the term x, and then half the coefficient of 6, so the number in front of the regular x. Well, half of 6 is 3. And then wrap that nicely in a square. And the second bit is copy out the plus 10, and then the final bit is to always subtract the thing you just halved, so basically square the 3. So it'll be minus 3 squared. And you're done, guys. And now we just combine the plus 10 and minus 3 squared. Well, in your calculator, plus 10 minus 3 squared, which is 9, so 10 take away 9 is 1. So our final result would be x minus 3 squared plus 1. And yeah, that's it. You complete the square. Now for part 2, Hence describe fully the single transformation that maps the curve of equation y equals x squared onto the curve of equation y equals x squared minus 6x plus 10. Okay, so how do you move from here to there? Now, keyword guys, every time they use the word hence, it means use your previous result. In other words, use the result from BI, that one. Okay, so comparing y equals x squared and y equals x minus 3 all squared plus 1. We can see now that they've inserted a minus 3. So this is a shift in the x-axis by 3 points. And this is plus 1 outside. So it means it's gone up by plus 1. So a nice way to say this is that we can say that this entire transformation. So simply put, we can say that this entire transformation is a translation. Okay, so that's one mark. You say the word translation because translation means a movement. And you say a movement what? You can say a translation of 3 and 1. Now this vector means that, well, the 3 means that it's moved across the x-axis by 3 points, and the 1 means it's moved across the y-axis by 1 point. In other words, it's gone 3 to the right and 1 up. And that's exactly what this means. Yeah, and we're good here, guys. Now for 23, it says ABCD is a kite with AB equal to AD and CB equal to CD. I think it's good we just draw this right now, yeah? So you got kite, we just draw a regular kite, yeah? And a kite always has two equal lengths, two matching pair equal lengths. So for example, these two would be equal, maybe that looks horrible, and then these two would be equal. Now it tells us here that AB equals AD, yeah? So if we just wrote this as, I don't know, AB, and this one being AD, therefore we can call this one CB and CD. Okay, so this looks okay so far. Now it says B is the point with coordinates 10, 9. Okay, so we can say this one has coordinates 10, 19, sorry. Whereas D is the point with coordinates 2, 7. So this has coordinates 2, 7. Now find an equation of the line AC. So AC, AC. Okay, so it's a straight line going down here. So we're talking about cutting it straight across. Okay, AC. Give your answer in that usual form. Okay, so easy trick for this, guys. Such an easy trick. The trick is that because you know kites have two pairs equal lengths, we can pretty much work out the length of BD, because BD is basically perpendicular. Even though my graph doesn't say so, we can work out the length of the equation of BD and then just flip the gradient using the perpendicular rule and work out the length of the equation of AC. So let's do BD first, yeah? We can say for BD, we can work out the gradient of that line. Well, the gradient of that line is always the change in y coordinates over the change in x coordinates. And we need the points of B and D to do that. So looking at the points of B and D, we can say that, well, the change in y coordinates would be 19 take away 7, which is 12, and 10 take away 2, which is 8. Okay. And well, you could simplify that if you want, yeah? But we could do that in the next step. Therefore, we can say that for line AC, this is clearly perpendicular. So that means the gradient for this line will be the negative reciprocal. And that's what you do. So negative reciprocal means you flip it upside down and then you flip the sign. So it becomes a minus 8 over 12. Yeah. So that's good so far. And just for the sake of it, guys, we should simplify the fraction. And you should get now minus 2/3. Now we got pretty much our gradient here, guys. So what's next? Okay, so let's write our equation out. So the general form of equation, and this is a straight line, yeah, is always y equals mx plus c. So updating this, we have y equals minus 2/3 x plus c. So our final step now, guys, is to literally figure out a point for a coordinate on this line to work out c. Now the question is, where do we find it? Well, conveniently, guys, you can see like from the shape of the kite, the midpoint is actually halfway between B and D, and also halfway between A and C. Technically, we can just work out the midpoint of B and D, and that's a perfect point on the line of AC. So let's work out the midpoint, yeah? Let's call this midpoint M, yeah? So we can say to work out any midpoint, the trick is to literally add up the pair of coordinates. So for example, add up 10 and 2 for an x coordinate, and then half it. We can see that 10 plus 2 is 12, so we've got 12, and we half it. That gives you your x coordinate. For the y coordinate, we do 19 plus 7. That should give us 26, and you half that as well. Therefore, resulting each one, 12 over 2 is 6, 26 over 2, guys, is 13. And that's nice, because that's a point on the line. Now, we're going to substitute this coordinate into this line, and then solve for c. So this means when x is 6 and y is 13, we can put this in. So replace y and x with 13 and 6. We should therefore have 13 equals minus 2 over 3 times 6 plus c. And yeah, guys, now if you just work this out, you can see that minus 2 over 3 times 6 in your calculator will give us minus 4. Scroll this down a bit. And then, copying out the rest, you got 13 and plus c. Therefore, adding 4 across, guys, you should get c value of 13 plus 4 is 17. And yeah, I think we're basically done now. So now we know what c is, so we can update our equation once more. So it's now going to look like this. We now got, therefore, y equals minus 2 over 3x plus 17. Now going back to the question tells us to give your answer in the form of py plus qx equals r, where p, q, and r are integers. Okay, so rule 1, we got to put x and y on both sides and make it equal to a number, and then clear out the fraction because they don't want fractions. So let's do it now. Let's move 2/3 x across so we can add it across. So it look like, where is it? Y or x first? Okay, y is first. So it's going to become y plus 2 over 3x equals 17. And now all you want to do, guys, is literally clear the fraction. So to clear the fraction, if you got a 3 at the bottom, just multiply the whole set by 3. If you do that, you're going to get 3y plus 2x because the fraction is cleared. And then 17 times 3 is 51. And that's it, guys. This should be a result. 3y plus 2x equals 51. Now, let's go into number 24. So this is actually the last one, guys. And fine, and you know what I like about this? They actually don't waste any paper for once. Because they always have like, blank page or something. Like, who does that? Alright, number 24 though. So a particle P is moving along a straight line that passes through a fixed point O. The displacement S, so displacement is pretty much a vector form of distance, like how far you travel from a certain point, of P from O at time t is given by the following equation. So S is your displacement, t is your time. Find the value of t for which the acceleration of P is 3 meters per second. Okay, so this is secretly a differentiation question in disguise, yeah? And how to figure this out? Well, you always have 3 components. You have the displacement, you have the velocity, and then you have acceleration. And to get to each component, you have to differentiate across. So to go from S to V, you go differentiate. To go from V to A, you differentiate again. So essentially, we need to differentiate this equation twice, guys. So let's start with that. So let's work out velocity first. To do that, we need to differentiate the S equation with respect to T. So differentiating this equation, guys, to differentiate, all you do is literally drop the power and then subtract the power by 1. So for T cubed, it becomes, you drop the power, you get 3T. Subtract power by 1, you get 2. That's it. If you got a number in front, do the same thing. Drop the power, so you get 2 times 6, which is 12. And then subtract power by 1, you got T to the power 1, which is just T. Now, if you just left with a T on its own, that vanishes, so you got 5. Yeah, just 5. And then if you got a constant, well, there's no T, so it becomes 0. And you left it like that. Now, to get acceleration, guys, again, we go differentiate this equation with respect to T. Doing the same thing, drop the power. 3 times 2 is 6, you got 6T. Because you just got a T left, it would just be minus 12. And yeah, guys. Now, the final step, guys, is looking back at the question, it says find the value of T for which the acceleration is pretty much equal to 3. In other words, replace A with 3 and solve for T. So since A is 3, copy the whole equation. So you got 6T, y is slowing down, minus 12. Okay, hold on, is it working good? Yeah, it's working. So to find T, just solve for T. So add 12 across, you got 15 equals 6T. And lastly, guys, just whip out your calculator. Just write 15 divided by 6. And you should therefore get a T value of 2.5 seconds. Because remember, this is time, yeah? And we're done, guys. That's pretty much the whole paper done. And that was probably the easiest, I think the easiest final question we've seen in the new 4MA1 paper series. Usually they always give you a summation or some kind of really hard arithmetic question. But today, man, they gave you a nice one. So, yeah, not too bad. Not too bad. Anyway, I hope you guys enjoyed my video. If you guys enjoyed it, please give me a like. As usual, share with your friends and subscribe. Try and help me reach more subscribers, guys. So, more people that get a chance to watch this, they can benefit. And, I'm trying to reach this across the whole world. So at least everyone can, inshallah, have a watch on this and, hopefully improve their maths or anything else, you know. And if you get stuck in question, guys, just drop me a comment and I'll do my best to answer it when I can. But yeah, as always, thank you so much for tuning in and watching my video, guys. I really appreciate it, and I'll see you guys in the next one. And that's it. Ciao.